ECT 206 Computer Architecture and Microcontrollers. Here module 2 8051 microcontroller and its architecture. So in this first section we are going to have a discussion on what are microprocessors, what are microcontroller, what are the difference between a processor and a controller, means microprocessor and a controller, basic differences, and last, what is an embedded system. Okay, so first of all, let us have an introduction or history to the microprocessors. Actually, the concept of first processors was introduced by Intel in year 1971 by introducing a processor 4004. This was just like a calculator to perform addition, subtraction, multiplication and division. They just introduced the concept of logical and or operations, like basic logic operation with this microprocessor. Later they introduced their main processors like 8085, 8086, 80286, etc, etc. So first of all, let us have what is a concept of a processor. Okay, so a previous semester you learned basically main digital electronic circuits, wherein we discussed about an adder circuit. Okay, a simple half adder circuit. So what is an half adder circuit? There we have two bits, say A and B, and we have two outputs, we call it as sum and carry. So according to the input A and B, we have the different options for sum and carry. For example, we have 0 0, sum will be 0, carry will be 0, and A equal to 0, B is equal to 1, sum will be 1, carry will be 0, and here A is equal to 1, B is equal to 0, sum is 1, carry is equal to 0, and for 1 1, both inputs are high, our output is going to be sum 0 and carry 1. For this logical or truth table to be implemented, we need sum by means of an XOR gate and a carry by means of a AND gate. For so simple circuit to illustrate the operation will be, so we have a XOR gate here. This is the symbol of an XOR gate. Sorry, this is a symbol of an XOR gate. There is no bubble here, sorry, where A and B are input and here is our sum, and we need an carry by means of a AND gates. So A and B, same inputs A and B here also, and we will get a carry here. Okay, so we need IC 7486, an XOR gate here, and 7404 and AND gate here. 7404 or whatever it may be, I forgot anyway, an AND gate here. So here is an AND operation to make the carry and XOR operation to make a sum operation. So we need two basic ICs here to implement the simple half order circuit here. The same we can implement by means of a processor here. So we have any general purpose processor. I am going to mark here as a processor. Okay, so here is a processor. I am going to call it as central processing unit, where we have some logical unit here, arithmetic and logic unit here, some registers here, some flags here, etc. Mean components of an ALU or CPU, where some ports, IO ports also will be available for inputting the inputs, and some output ports also available for getting the outputs, and some timers also available internally. So these are all the peripherals of the CPU. So here these IO ports, we can input units, you can use it to input the A and B's, and the output sections we can use it as to demonstrate what will be the output. So with the simple this processor we can implement without using this XOR gate and a AND gate the same half order operation. So we need to use dedicated two input pins for A and B as the inputs, and two output pins sum and carry, and some basic or simple programs also we need. Some programs also we need to use with this processor to implement this logical operation. So the advantage here is we have used or we have dedicated here these ICs for the implementation of this half order and will perform this sum and carry operations only. Okay, and here advantage is we have configured these pins A and B as input and S and C as the outputs, and we have a program to implement this, or simply by changing the program with some another code we can use the same processor to implement some another function. So that is the advantages of a processor. So same processor we can use, or we can avoid these connections, and we can configure this as another set of, say, full adder with implementing one more input and the same and changing the program. We can make simply we can modify the same processor to work as a what is called full adder. So the same we need, if we need to go for complicated circuit, and it will take a time and it will not be a cost effective method. So the processor, this is the simplest advantages of what you say a processor. Now let us have the discussion on to our module 2 8051 architecture, and here we are going to have discussion on processors. So what are the processors? So basically for our first processors was introduced by the company Intel. Then the populars are 8085, 8086, 80286, 80386, 486 Pentium, now dual core, Core 2 Duo, then now it's what you say i3, i5, i7, etc. Many processors, higher end processors are available from the Intel Corporation. And so see, these all are from the Intel family and are known as Intel's x86 family of processors. And another set of processors are 6800, 680, 6810, 20, 30, 40, etc. And as we are moving from here to here, the processors become at the higher end. And these all processors are from the Motorola and are known as Motorola's 680X0 family of processors. Now, what is an architecture, or what will be the inside of a processor? This is the simplest representation of a processor, where we have a CPU, see, in the general purpose microprocessor, a CPU is known as CPU, Central Processing Unit. You might have learned in class or semester 1 regarding the representation of a general purpose computer. So we have a microprocessor here, and the microprocessor itself is not able to perform any function unless it is supported with these extra components. So extra components are RAM. RAM is random access memory, and ROM, read only memory. Then we need to support with IO port, we need to provide timer, we need to provide serial COM port, etc. Where in this IO port we can use to configure keyboard, mouse, monitor, etc. RAM is using for what? You might have the knowledge of the RAM and ROM for what we are using. RAM is using for using or storing the data temporarily while executing a program. ROM are using for copying or storing the permanent data within the computer, and timer for different timing operations or synchronizing the operation of the microprocessor or the computer, and serial COM port also for communicating or interfacing with some external devices. Okay, now these external devices are communicated with the central processor or CPU through two buses known as data bus and address bus. Address bus is nothing but the lines, some lines from the microprocessor that are going to the all internal or external peripheral devices to address each of them. Okay, so address will be unique, and we can change the access to the different external devices by simply changing the address lines 0000 configurations. Okay, so depending on the number of lines on this address bus, we have the microprocessor ranges from 8085 to 80486 and Pentium, then higher end. As we are going to the higher end, number of address lines and so memory and peripheral devices also increasing. And the data bus is nothing but wherein data from these external devices are flowing to the microprocessor to the CPU. So the CPU or the main processor microprocessor will access the data from these external devices by providing proper address to the system. Okay, so there are separate control bus also, control lines also, to properly give the address and data from and to the microprocessor. So to the working of a system, a microprocessor need to support with RAM, ROM and external peripheral devices like this. Okay, so this is a architecture of a microprocessor. So generally a general purpose microprocessor, it must add RAM, ROM, IO ports and timers to make them functional. This is one of the point to be memorized while discussing with a microprocessor. And by adding so, then the system become bulkier and expensive. This is the second point. Third point, but the designer have the freedom on the amount of RAM and ROM and IO ports to make the cost effective system. For example, if you want to make a small purpose or a small level of computer, you need to have a small, you need to support it with the RAM and ROM in less amount, so that for example atom processor microprocessor computer is so designed to handle with say simple word and internet chrome operations only. They are not able to use for developing say Adobe Photoshop like operations. Okay, and if you want to do use with a simply or complicated gaming computers and also some other higher end purposes, you need to provide a computer which is having a large amount of RAM and ROM. Okay, so the designer, according to his freedom, according to his wish, he can have the option to design his own RAM and ROM based computer system. That is one of the advantage of a computer microprocessor based computer system. Now we are having architecture of a microcontroller. Here is the difference between a microcontroller. A microprocessor need RAM, ROM and timer, external devices, etc. to work it as a its own functional unit. While here a microcontroller, it is all integrated into a single chip. All means all those discussed with the microprocessor. What you call a small amount of all these RAM and ROM, IO ports and timers, etc. all are built into a single unit. All are built into a single unit, into a single chip. All are built into a single chip. That is a microcontroller. So inside a microcontroller, we have a CPU, central processing unit, and a RAM which was external for the microprocessor. There is a ROM that also external. There will be some IO ports, there will be some timer, and there will be serial COM ports, etc. within the microcontroller. So and the availability of these RAM and ROM and IO ports are varying from microcontroller to microcontroller, and so the designer have the freedom to select the different or it's his own microcontroller according to his requirement. So that is a microcontroller and a microprocessor architecture wise difference. Okay, so let us have a discussion on microcontroller. So microcontroller have a built-in CPU and a fixed amount of RAM and ROM IO ports and a timer within it. Second point, the designer cannot add any external memory or IO or timer. External memory, IO or timer. So designer no need to add, no need to support with external memory. And so this is the third point, fixed amount of RAM and ROM and the power it consume. So power it's going to be consumed it will be in the very low level range. Most of the microcontroller based systems will be operating with battery. Means the amount of power is going to be in less quantity only. So these all factors makes them ideal for designing a system in which cost and space are critical design factors. The space of the system, we don't want to have external many memory or peripherals, so space is going to be a reduced system, and the cost also. Most of the microcontrollers are having RAM and ROM within it, even though which is very few, it is available within it, so cost is going to be less compared to a microprocessor based system. Okay, now here is the second important point, comparisons between microprocessor and a microcontroller similarities. Okay, first, Microcontrollers both have got CPU, ALU, and registers. This is one of the similarities between a microprocessor and a microcontroller. Both are having a CPU and arithmetic logic unit, and there will be some registers. Registers and all will be dealing later. Registers are some say locations wherein the microcontroller or processors will store their data while doing operations or execution. And microcontroller and microprocessors have address bus, data bus, and control bus. These are all commons. Address bus are there for both microcontroller and processors to control or to access different locations within the system. And there will be data bus, a number of lines to carry the data to and from the microprocessor and controller. And there will be some control bus. Okay, there will be the system should provide a proper controlling signals, whether to read the data, whether to write the data, whether to operate some as a printer, whether to put the data to the monitor, etc. So control lines also are common for both microcontroller and microprocessor. Okay, and here is what is address bus and data bus. Address bus carries data which point to specific location on memory or external device. Data bus carries data to and from microprocessor and controller. Control bus carry control signals. So these all operations and functions also common for both microprocessor and microcontroller. Next, microprocessor and microcontroller differences. This is going to be an important point in this section. Okay, and is a regular question in most of the university papers. So microprocessor and microcontroller differences. Okay, so microprocessor and microcontroller, we are going to have a comparison here. Microprocessor and microcontroller. First point, microprocessor. Microprocessor need already, even though we already discussed all these points, here is a comparison you can prepare and also from this. Need ROM, RAM, read-only memory, random access memory, input and output ports, timers, etc. Externally, need external, that's important. They all are externals. They all are external to the processor. Microcontroller, when no need of any ROM, RAM, IO, and timers externally. They are all internal. That is an important point here. Now, external ROM, RAM, and IO ports and timers makes the system complex and expensive. See, this is the point in microprocessor. External ROM make the system more expensive and complex, bulkier. Okay, so within a single chip in microcontroller all are available. So that's the next point here. Internal ROM, RAM, and IO ports and timers make system simple, cost effective, and space effective. Cost and space effective, simple and cost and space effective. That's an important point as far as the microcontroller is concerned. Microprocessors all are having external designer how to provide them separately, so the cost will go high and the system space also go high, or the component or the system will be bulkier with the microprocessor system. And the next point, microprocessors have opcodes. Opcode is nothing but operation codes. Operation codes means some instructions, code to instruct the microcontroller and microprocessor to do a work. So microprocessor instruction set we are going to learn later. So opcodes for moving data from external memory to the CPU. That's an important point. Microprocessors, how their instruction set mainly belongs to the group of instructions which move the data from to external memory to the central processing unit. And in microcontrollers have one or two opcodes for moving data from the external memory to the CPU. Why? Because here most of the codes and data are residing within the microcontroller within itself. Okay, so that is the important point as far as the microcontroller is concerned. Another set of instruction, another set of comparisons or differences. Processors have bytes handling instructions mainly. What is bytes? So byte means 8-bit data. Bytes means 8-bit data. And the another point is nibble, which is 4-bit data. Anyway, in microprocessors, most of the instruction sets are byte handling instructions, while in microcontroller they are having bit level operating instruction set. Okay, so mainly microcontrollers are checking the signals at its IO lines, input output lines, and are individual lines, and either 0 or 1 available. 0 means logic low, 0 voltage, or 1 logic high or 5 voltage is whether available within the pin is the microcontroller is checking always. That's why their instructions are mainly belongs to the group of bits handling instructions. And microprocessors are used for general purpose applications only. Okay, microprocessors are used within the computer. Microprocessors, we are all knows what is microprocessor, and we are buying microprocessor, a computer, by specifying the name of the processor, like whether it's i5 or i7 or i3, and generations also. These all indicates some parameters, design specifications of the computer system. So microprocessors are used for general purpose applications like Windows operate within the operating system. We have the Word and Adobe Photoshop, Paint, Internet, Chrome, whatever it may be. Different applications can be loaded to the microprocessor or to the computer as and when it's required. Okay, so that is the microprocessor based system, while a microcontroller is program specific and designed for particular applications. Microcontroller is program specific. That meaning microcontroller based systems are designed for a particular purpose. Only for example, within a washing machine, what is the purpose of the washing machine? Washing machine will allow some time to fall water, some time to fill detergents and some other ingredients within the washing system, and it will allow some time to make the motor to rotate, motors to make the drum to rotate and drain the water, and some other extra functions. So the ones we design a washing machine system using the microcontroller, that microcontroller is intended to work for that operations only. Okay, then if you want to use the same microcontroller for another operations, you need to completely erase the program for the washing machine operation, and you need to reprogram it for doing with some other operations like a printer. If you want to use the microcontroller that we are used for washing machine to use it as a printer, we need to erase the previous program and to load with a new program, new set of instructions to operate as a printer. So that is a microcontroller difference. And microprocessor transfer code and data very fast from external memory device to the chip. Okay, processor transfer code and data very fast from external memory to the device. Microcontroller is concerned with the fast movement of bits within the chip. There bytes of data are flowing external from external to the chip. Here fast movement of bits are concerned. Okay, so these are the points that to be memorized while if they are asking you about the difference or comparisons within the between the microprocessor and the microcontroller. Now here we have a point here, embedded system. What is an embedded system? So an embedded system is a microprocessor or controller based computer hardware system with a software that is designed to perform a dedicated function either as an independent system or as a part of a large system. Embedded system is an important branch of engineering and nowadays. Okay, so it's microprocessor or microcontroller based system with a hardware and software. Software is embedded into the hardware, both embedded, integrated, both are into the same system, both hardware and software into the single unit. For example, our previous example, say washing machine, wherein we have the motor, drum, some water level sensors, some pressure sensors, etc. are hardwares, and these hardwares are to be synchronized or are to be controlled with a software. Okay, first allow the water to fill within the drum, then drum to be what you say rotate, rinse for some time, etc. Different operations are to be controlled with the software, and after that the drainage valve to open at a proper time, etc. These all functions will be controlled with the help of the software within it. So there will be a microcontroller within the washing machine that are programmed with the specific utility. So these all we can call it as a an embedded system. Right? Another example is you have what given on the example what is called a calculator, a scientific calculator, normal calculator. Then calculator is supposed to do addition, multiplications, and some engineering math-based equations, operations, etc. So according to the button we are pressing, the software decides what kind of operations it is supposed to do. Suppose either it is for addition, first it should load the data, and then according to the operator key, second data, then as per the on pressing the equal sign, the required operation is to be performed and the result is to be displayed on the display section. So all are within a small chip. That chip is the microcontroller and embedded with the software. So that is an embedded system. Okay, so how embedded system differ from a PC? That is the important point we need to discuss here. How an embedded system differ from a PC. Okay, here a PC can be used for any applications. Microcontroller, personal computer can be used for any application like a word processor, video games, a teller machine, a bank teller machine, network terminal, or as an internet terminal. So we can use the our personal computer or laptops, any of the operations like mentioned here. And the software for all these applications can be loaded and run as and when needed. Suppose for example in the morning you're supposed to use the computer to do your some assignments and Word. Okay, you can load the computer with the Microsoft Office tool Word, and then you can act within the software. And later if you want to use that same computer for browsing the latest news or internet, what will close the applications previously open and we open with the Chrome or some other kinds of browser, and we will browse according to our requirement. Okay, so that is the point. And inside a PC we have a number of embedded systems such as keyboard, monitor, mouse, etc. So personal computer itself is having some embedded components such as keyboards, monitors, etc. So what is called a keyboard. Why keyboard is an embedded system? Keyboard that contains some processor inside, some microcontroller processor inside, that is according to the key we pressed, it will identify which key and inform the user the key being pressed. So that is an embedded system. The keyboard cannot use for some another applications like say printing. Monitor is also, it's only for you printing or showing some data. Mouse, it's only for showing the location of a cursor and for some click operations. So that our keyboard, monitor, etc. all are embedded system that's also integrated with the personal computer. And what is the need of an embedded system? Why we need to go for an embedded system? Okay, so suppose if you want to implement the washing machine with a computer, we need to provide some cables and some control lines from the computer to the washing machine. And suppose we are able to implement the operation of the washing machine with the computer, and later if you want to use the same computer for some other operations, you need to break out all these connections, and all the programs that are being loaded will be we need to remove it, and system will be very, very complicated. Okay, so if we use a microcontroller for the same purpose of washing machine, it will be a compact size and will be very cheap. Okay, so to decrease the power consumption and space, first point, to decrease the power consumptions and space. Okay, then to save money and shorten the development time. money and shorten the development time. So if you use the computer for the washing machine, we need to have all the sort of connections, all set of connections, and the program will be complicated, and all these connections and all make the system more expensive. So we need to go for a specific microcontroller based embedded system for such a case. And vast library of software is already available. For example, if you want to use a microcontroller with what you call a keyboard and interfacing keyboard and the microcontroller, the library, you don't want to have a program for your own program for interfacing a keyboard. A variety of programs are available, already developed and are freely available. Okay, so that vast variety library of softwares are already available, and we need to have an embedded system for a small and basically small specific applications instead of going for a computer. Now within the microcontroller based what you call embedded system, how will you choose a microcontroller? Now according to our requirement, we have to go for different there are different microcontrollers available in market depending on so we must have some points. So first point is, depending on the computing needs, should be hand efficiently and cost effectively. Computing techniques should be efficiently and cost effectively. Accordingly, we need to choose a microcontroller. Now what are that factors? Speed. So with what speed, maximum speed our processor will operate. Most of our microcontrollers are operating with megahertz only, while computers are operating at gigahertz. Even though at a very high speed, we are not going for a small purpose specific applications with computer. We will be going for an embedded microcontroller system only. So speed of the microcontroller is an important point while choosing a microcontroller. Another point, packaging. Different types of packages of ICs are available. Packaging like DIP package. DIP means dual inline package. Dual inline package IC like this. It's available. Ports are being arranged in 2 lines on either side of an IC. So such ICs will be compared to other side, either IC will be bulkier, even though it's very popular. So IC is a microcontroller will be integrated. IC will be in this structure, dual inline package. So packaging is some another ICs will be having a small like this, and that lines will be very close and will be in and around all sides of the IC. We have the IO port lines, and these ICs so structure will be very compact compared to this DIP structure. So this is DIP structure, and this is surface mounted ICs. Such ICs are surface mounted ICs. Okay, such ICs are very popular. If you open a laptop, you can see many, or microprocessor itself looks like this. So packaging also an important factor while designing or while choosing a microcontroller. Another, power consumption. So what is power consumption? Power consumption is how much power, how much voltage and the current V into I is going to be consumed while operating with our application. For example, if you most of our embedded based systems will be operating with what you call its batteries. For example, nowadays the bus operators or a bus conductor is using a printing machine, a small handheld equipment for printing the ticket. Okay, so inside we cannot connect a power adapter to a 230 voltage to work with this. So we will plug in with what you call a battery, or we have a rechargeable battery. Anyway, it's going to work with a 5 voltage or a 9 voltage battery. So if your microcontroller is consuming more power within say 10 minutes to 15 minutes, our battery will be drained and the system will going to be in the die condition, in the dead state. So we should have a controller which will consume less power throughout its operating period. So power consumption is also an important means very important factor while designing an embedded system. Another point, amount of RAM and ROM on the chip. Okay, RAM and ROM, this decides the speed of operation of the system, RAM and ROM. So most of the microcontrollers have a variety of variant which provides different level of different amount of RAM and ROM. So if you have a small amount of what you call the instructions sets within the microcontroller, within your what you call the applications, you can go for a small amount microcontroller which is having small amount of RAM and ROM. If you have a more complicated or more lengthy application instructions or healthy program within your system, you need to have a microcontroller which is having a large amount of RAM and ROM within the chip. Okay, so that is the another point that should be considered while choosing a microcontroller. Another point, number of IO pins and the timers on the chip. Okay, for example, if you want to implement a simple half adder only, you need to have only 2 input lines for the input and 2 output lines for the output. So you need to go for a tiny microcontroller for that operation. Okay, if you want to go, for example, you might have seen a large scrolling display like advertisement display panel within the shops nowadays. They are very popular, very common nowadays. These type of microcontroller based embedded system, they need large number of IO lines. Okay, 2 or 4 or 10, it will not be sufficient for such a operation, such a function. So we need to have a microcontroller with a large number of IO lines and timers on this concept. Okay, so according to our requirement, you must choose a microcontroller with IO points and timers, and easy to upgrade to higher version. Okay, so suppose nowadays our requirement, when the design was going on, our requirement was very less. So you must consider a microcontroller. In future, the same customer may ask you to develop the system, to modify the system, to have some another functional utilities also. So if you are going to change the microcontroller with this another set of another company's microcontroller, your existing software and system entirely is going to collapse. It means one firm microcontroller instruction set or program is not going to work with another firm's instructions, another firm's program. So both programs will be entirely different. So you must select a microcontroller whose upgradations will be very easy and less what you call economical. Okay, very easy, and it should be economical. And the cost per unit. Okay, you must have our embedded system. Most of the embedded systems will be some products that is to be introduced into the market. So to have the profit from our products, we should design a system with less cost. So cost per unit also an important point while choosing a microcontroller. And last, how to choose a microcontroller. Ability of software development tools such as compilers, assemblers and loaders, etc. Okay, our system must have a software. Okay, so the availability of the software development tools, compiler, assembler and loaders, etc. are also important while choosing a microcontroller. And wide availability of reliable source of microcontrollers. What do you mean by that? If you select a microcontroller, we should not be depend on a particular firm. Okay, the same set of microcontroller will be supplied by another firm. If one firm increased or reduced the supply or stopped the supply, other firms microcontroller should be available in the market. So 8051, one of the popular microcontroller 8051, this chapter itself named 8051 architecture, so has the highest or largest number of suppliers. So suppliers are Intel, Atmel, Philips, AMD, all are producing 8051 based the core architecture of 8051, even though different companies have different peripheral or memories and the timers will be different in the what you call the in the chip, while program set of instructions and everything will be same for all these set of microcontrollers. So the point wide availability of reliable source of microcontrollers also to be an important point while choosing a microcontroller. And this is the sections.